Goodbye. Have a good day. Welcome to my video on Bizarro Differentiation, where everything is backwards. Right? When we're trying to basically perform an integration, we just have to remember we're working backwards on the derivatives work that you've done so far this year. Hopefully, you'll be okay with the homework that I assigned on Friday. But this video will cover some additional methods of integration that will help you with the problems that the sub will give to you on Monday in class. So, first example that I'd like to look at is this problem here, where I want you guys to integrate the integral of x squared parentheses 4 square root of x plus 3. Similar to when we found derivatives, when you're trying to find an antiderivative, the integrand that you're looking at, if you can do any particular algebra that you've done in the past, that you know in the past, if you perform the algebra to your integrand, that might make your life easier to help actually find an antiderivative. So here, because we have the monomial term of x squared in front of the binomial term, what we could perhaps do to start this problem off is to actually distribute the x squared into the binomial that we have there. So that would give us, we have x squared times 4 square root of x, we would have 4x to the 5/2 power, then plus 3x squared. And as we discussed in class on Friday, now we have a sum of two terms. We could essentially consider each term separately, try to find the antiderivative to come up with our overall final answer. So the other thing, I guess, with the 4x to the 5/2 power, we know that the constant of 4 is just going to get carried through to our antiderivative. So the antiderivative of 4x to the 5/2 power will give us 4 times the antiderivative of x to the 5/2 power would be x to the 7/2 power multiplied by, or over, I should say, 7/2. That's the same as multiplying by 2/7 x to the 7/2 power. And then the antiderivative of 3x squared, again, the 3 will just get carried through to the antiderivative. And then the antiderivative of x squared would be x cubed over 3, which is the same thing as 1/3 x cubed. And then don't forget the plus c on the end. Right? You can leave your answer in this form. You don't have to simplify your answer for your next particular test if you don't want to. All right. So again, you can try and perform algebra, any type of algebra, whether it's distributing, FOILing, perhaps reducing fractions down. You can always try and do that first to help actually try and find antiderivative. But there's going to become a point when that's not going to become feasible. So another method of integration that we have is integration by substitution. If we look at this particular problem here, you're asked to integrate, which means again, find the antiderivative of 2x times x squared plus 20 all raised to the 72nd power. Now, I guess you could actually try to simplify this algebraically, but it would take you just way too long. So the first particular method that we have of integration that isn't just using your antiderivative rules is this integration by substitution. So integration by substitution is really the reverse method of the chain rule. And so because that is the case, let's actually recall again how we handled finding the derivative by using the chain rule. Right? We did this when we had a composition of functions. Let's call it y equals f composed of g of x. And what we did was we first identified what the inner function was, and we said in this case, we can say in this case, u equals to g of x. And this allowed us to rewrite the outer function as y equals to f of u. We then proceeded to calculate the derivative of the inner function, which here I'll represent that with 2 dx, or g prime of x. And then we also derive the outer function, which again in this case I'll call dy du, or f prime of u. Then the derivative of the whole kit and caboodle original function would be dy dx, which was found by multiplying the derivative of the inner function by the derivative of the outer function. Now, when we did this, we used the notation du dx and dy du, but I'm going to rewrite that now, the derivative of the inner function as g prime of x, and the derivative of the outer function, I can call it f prime of u, but remember u is just equal to g of x, so I'm going to call that f prime of g of x. And I want to rewrite it this way because this expression here is going to be essentially your integrand, right? Remember that when we're integrating, we're working backwards, and this whole expression is kind of what you're going to be starting off with. And this notation here hopefully highlights the fact of what we could potentially use and help see to help us find an answer. Because this expression here, f prime of g of x, really kind of highlights perhaps how we can get back to our original composed function. And then the other potential thing is that inside of that f prime of g of x, the g of x there, that inner function, we should see that derivative located inside of our integrand as well. So, particular steps that we can use to help perform this integration by substitution are listed here. The first thing that you want to do when you're trying to do integration by substitution is to find u, the inner function. Second, you then want to calculate the derivative of that inner function. We call that du dx. Then, step 3, you want to solve for du from that du dx expression. Fourth, you then want to make your substitutions for u and du into your integral so that you get everything in terms of the variable u. Once you've done that, we move on to step 5, which will be to integrate our expression. And then the last step will be to plug back in the original variable to come up with your final answer. Now, this may all sound really confusing, but I'm going to now go back to that original problem, and we're going to apply these steps to actually find our antiderivative. So, the first step again to solve this integral is to solve for u, which is going to be our inner function. In this particular case, the inner function would be x squared plus 20, right? Because that is inside of the 72nd power function. Second step is to find the derivative of this expression. We call that du dx. Well, the derivative of x squared plus 20 is simply just 2x. Now, the next step after this is to solve for du. And we're allowed to split up the du over dx because if you think of it, or if you recall, right, the derivative is the same thing as the slope of your tangent line. And a slope is essentially like a delta y over delta x calculation. So that allows us to kind of separate or to solve for du in this derivative expression. And we will have, or when we solve for du, we see that that is equal to 2x dx. Now, when you're doing this integration by substitution, it's at this point that you kind of know whether things are going to work out properly. Because 2x dx, I see the 2x over here in my original integral, and obviously with every integral we start off with, we have the dx there. So that's going to allow us to actually now perform our substitution properly. Because the next step is to make our substitutions, and so our original integral, right, will have that u is going to go in for x squared plus 20, so we'll have then u to the 72nd power, and du is going to take the spot of 2x dx, so we'll just have essentially du at the end. Once you've made all the substitutions, you have to make sure that all the variables are in terms of u. In this case, that is the case. And now we're allowed to integrate. The antiderivative of u to the 72nd power is u to the 73rd over 73 plus c. And the last step is to substitute back in our original u, original variable. And so that would be x squared plus 20 in for u. And so we have x squared plus 20 to the 73rd power all over 73 plus c. So here's a last problem that we'll look at. This will also involve u substitution, and I just want to show this particular problem because sometimes when you do your substitutions, you might have to make a little adjustment. So here, again, obviously, we can't just integrate this expression as is, x squared times sine of x cubed plus 17, nor can we do anything algebraically to simplify this. So substitution, method substitution, is what we'll try and do to integrate this. The inner function here, well, hopefully we agree that x cubed plus 17 is our inner function. The derivative of x cubed plus 13 is just 3x squared. And if we solve for du, we get that du is equal to 3x squared dx. Now, again, it's at this point, usually when you calculate your derivative, that you start to see whether things are going to work out. And our derivative du, or what we have du equal to here, is 3x squared dx. I look back at the original integral, and I don't see exactly 3x squared dx. But what I do see here is x squared, and obviously dx. And being off by a constant with du is totally okay. We can make an adjustment to that du so that we'll be allowed to then make our substitution in and get rid of the x squared dx in our original integral. So what we can do in particular here is that if du is equal to 3x squared dx, that means that 1/3 du is just equal to x squared dx, the expression that we have left over in our original integral. So now that we know that 1/3 du is equal to x squared dx, we can make our substitutions. Again, we have that u is equal to x cubed plus 17, so I'll make that substitution in, u in for x cubed plus 17, and for x squared dx, I need to put in that spot 1/3 u. Now that my integral is solely in terms of the variable u, I can integrate. So in particular, I can move the 1/3 out in front of my integral sign. The antiderivative of sine of u, we know, is negative cosine of u plus c. And then, again, we substitute back in our original u, what u was originally equal to, x cubed plus 17, to get our final answer. So hopefully that helps explain some of these other methods of integration. The problems that the sub will give to you on Monday will hopefully help you practice simplifying integrals first to help try and find antiderivative. And then the other problems will be when you can't simplify algebraically this method of integration. And then on Tuesday, we'll go over those problems to help make sure everyone is okay. I hope you have a great weekend, and I'll see you guys on Tuesday. Don't forget, second period on Tuesday, I'll also bring in bagels, and hopefully have a nice period before the vacation break. Take care.